GraalVM can compile your Java applications into native images. But why would you do that? The native images already speak the language of their host systems. They do not need further translations or interpretations. So, one of the main benefits, your applications are more efficient. Now, let's level up the complexity. Imagine your Java applications need to work with code written in other languages such as Python, JavaScript, C, and others. Is there a runtime for these languages that works with Java? If yes, how does that work? Can you deploy all these together in a single binary distribution? What kind of applications can you build with them? How do you monitor, profile, or debug them? I know these are a lot of questions, but I don't have answer to these questions. Our speaker today definitely does. Hi everyone, thanks for joining in for another episode of IntelliJ Idea Livestream. I'm your host Mala Gupta, and today I'm pleased to welcome Fabio Niephaus. Hey
Hi,
Fabio,
Mala.
it's a
Yeah,
pleasure to have you present with us today.
yeah, thanks. I'm Fabio Niephaus. I'm a researcher on the GraalVM team, and today we're going to talk about some GraalVM and GraalPy integrations in IntelliJ IDEA.
Thank you so much. I'm so looking forward to learn from you in this session. But before I let you take the stage, I have a quick question for you.
Yes.
So, as you know, as developers, we know and understand that naming is hard. And while we were talking about GraalVM, you mentioned some interesting naming that you have with the class names and different things at GraalVM. So, would you like to share that with the developers and people who are watching?
Yes. So one of the things that people always, or users often ask us about is they've been looking closely at the native image build output, and they see a line that says building universe, and that seems like very interesting, right? So this is one of the few places where we decided to leak implementation details. So inside of native image, there is a class, a universe. Well, there's actually multiple universes. There's even a class called Big Bang, which creates universes. And we thought it's so much fun that we have to share this with the user. So now when you're building an application with GraalVM and building a native image, the build output will show you when we are creating a universe for you. So yeah, I thought that was fun to share.
Oh, wow. Creating universes. That definitely sounds interesting for the developers. So I would not take much of your time. And before I let you take the stage, let me share some quick housekeeping details for everyone who's watching. Please use the YouTube chat to post your questions. Fabio will answer your questions. He'll take a break, and rest of the questions will answer towards the end of the session. I'll try to answer your questions. And we also have a volunteer from the JetBrains team. And yes, the most important question, this session will be recorded and it will be hosted on IntelliJ Ideas YouTube channel. So if you haven't already subscribed to our channel, now is the time to do so. And if you like today's session, which I'm sure you will definitely do not miss to like the video. And with that, Fabio, I will let you take the stage and I'll be backstage. Have fun.
Perfect. Thank you very much. Okay, so I thought before we start, I should mention that in this presentation, I'm going to show you a lot of different integrations, but I'm only going to touch the surface, so use them as a starting point. We're not going to dive very deep into each of them. I guess I could do a whole session just on one of them, but I thought maybe there's something that you didn't know that works in IntelliJ and with GraalVM, GraalPy, and other Graal languages, and I thought this would be a fun session to do. I'm going to use IntelliJ IDEA most of the time, and there's a web browser running as well. We'll use that later on. I hope I'm not going too fast, but as Mala already said, this talk is recorded, so you can watch it again on YouTube and other places. And the last thing that I wanted to mention before we can get started is that I don't consider myself an expert user of IntelliJ IDEA. I always, as someone passionate about developer tools, I always think it's fun to see others use developer tools. So today, I'm going to show you how I use some of the features in IntelliJ IDEA. But yeah, again, I'm not an expert. So if you think I'm using it wrong, if you think there's a better way of doing this, feel free to reach out to me or feel free to share online with others. And yeah, with that out of the way, why don't we get started? So yeah, so I work on the GraalVM team. I'm a researcher on the GraalVM team, and one of the things that, or the most popular thing probably that you have heard of GraalVM is native image, which allows you to produce very efficient native images that start up fast, that scale really well, and that are efficient in terms of compute. So we're going to talk about that. So this will be the first part of the talk. We're going to cover some getting started. We're going to do some JFR profiling and some debugging. Here are a couple of pointers if you want to follow along with some guides or some demos as a follow-up. And then in the second part of the talk, I'm going to walk you through some tools that you can use inside of IntelliJ IDEA for our Graal languages. So our languages, they allow you to supercharge your Java applications with, for example, packages from Python, JavaScript, and other language ecosystems. And today we're only going to look really at GraalPy and GraalJS. GraalWasm is there, WebAssembly runtime that you can use. We also even have a framework called Truffle for implementing these languages that you can use to implement your own. But again, there's also a repository with demos and guides if you want to dig deeper and play around. So yeah, we're not going to write a lot of code. We are also not going to build native images. I would assume that you have seen some of the presentations from my colleague, Alina, for example, or Thomas Wirtinger, the project lead, also talks sometimes at DevOps and other conferences. And so today I'm just going to show you a couple of things that hopefully you didn't know works in IntelliJ IDEA. So why don't we start with the getting started? And let me make sure that I'm tracking my time a little bit. So the first thing that I wanted to show you, these are just my notes, so you can follow along. So the first thing I want you to see is that you can install GraalVM right inside the IDE. So if you go into SDKs, you can go and say download a JDK, and you can pick a Java version, for example, 21, and then you can pick Oracle GraalVM or GraalVM Community Edition. Oracle GraalVM is the most advanced GraalVM distribution from Oracle, and GraalVM Community Edition is the open source version. So you can see it's on 21.02 because this only gets updates for a year, and Oracle GraalVM gets free updates for, I think, 3 years. And Oracle GraalVM provides additional features with more advanced compiler optimizations, PGO, G1GC, security features like SBOM. There's a lot of things in there, and you can use them all for free, even in production. So yeah, that's why I use Oracle GraalVM most of the time. And yeah, I can just click on download and it would download. I'm not going to do that because I'm streaming right now. But what you can see is that I already have set up a bunch of different GraalVM versions because I'm using SDKman, and IntelliJ integrates SDKman, and they are already being picked up automatically. So you can also install GraalVM JDKs with SDKman, and they will appear in here. Yeah, we'll talk about the Python stuff later, but that is also something that you can do here. Okay, so now that you have a project and you can configure it with a GraalVM JDK, you may be wondering, well, you know, I have a Maven or a Gradle project. How do I get started with GraalVM? And we have what we call the native build tools. So these are Gradle and Maven plugins that you can add to your configuration. So in the case of Gradle, it's just this line, and that you add this to your plugins. And then this allows you to build native executables of your Java application. Well, I'm not going to start a new project, new Gradle or Maven project here, and copy over some snippet. But what I want to show you is that you can start even more complex projects like a Spring Boot, a Micronaut, or a Quarkus project with GraalVM support right inside of IntelliJ IDEA. So what you're going to do is you go to File, New Project, and then here's a Micronaut generator, a Quarkus generator, a Spring Boot generator, and all of them, they look alike and they work the same way. They talk to the corresponding launcher. Let's go with Micronaut. So, and this is essentially what you can find on this launcher website, but integrated in the IDE. I like You can, for example, pick Maven if you want, or a different testing framework, and the JDK that you want to use. And when you click on Next, you can choose the features that you want to add. So just like on that website, here I'm using Micronaut 472, and then you can pick features. Well, I want to show you two features. One is in languages. There's a Micronaut GraalPy extension, which I'm just going to add real quick, but we're not going to build a whole application with it. And then there's also a view rendering project called React Server-Side Rendering, SSR. So this is a view rendering feature from Micronaut, which allows you to render React.js components, and this is using GraalJS under the hood. So if you want to use GraalJS and React.js, this is probably something that you want to try out. So you can even add this here, but let's just go with the GraalPy extension. When I press create, I will, well, IntelliJ idea, we'll just download the project, and let's see if that has worked, or did I press the wrong button? Let's try again. Okay, well, it has created project 7, but okay, languages, GraalPy, create. So yep, I need to select Maven. That's correct. Okay, that's what I was looking for. So I want to open this in a new window. And here's the new window, and this is now a fresh Micronaut project, completely empty with just this application boilerplate code. And yeah, it even has the GraalPy documentation in here, linked reference. So if you click on this, it will take you to the documentation of this GraalPy feature in Micronaut. And this will tell you how to install Python packages, and then also how to write Python code, put Python code in your Java project. And then you need to create Java interfaces. And with this annotation, you can wire your Java interface to the Python code. And then you can use a dependency injection and program against, for example, here, this dealer service, which is actually baked by Python objects. And GraalPy will take care of the rest. So this is something that you can just follow along from here, and it will just work in this project. Okay, but let's step back. So this is the getting started, how you start a project. But what about, like, you have a project running and you want to profile it, right? So one very popular thing is the Java flight recorder, and Native Image has support for this. So I thought maybe we start with a very simple example how this works. So here I just have a bunch of bash scripts, and I already ran the build native image bash script. So yeah, so the first lines are not that important. This just sets up the right SDKman version that I want to use. I'm actually using a JDK 24 EA build number 23. And then I'm building a native image, and building it with this JDK HTTP server, and I enable all monitoring features. Monitoring features like JFR, they add functionality, but they also add to the overall size of the image a little bit, at least. So they're not enabled by default. We need to enable them explicitly. So in Java, I can do -m HTTP server, and that starts the simple web server from the JDK. So if I click on the link, it will just list the directory that we see here and where we're running, in which we're running. And if I replace Java with native image, and you can add additional flags like enable monitoring, you will build a native executable that does the same thing. So, and we already have the binary here, and run native will run it for us. That's just a little script that helps me set up the service. So this is the binary, and we ask it to listen on port 8001, and we start Java flight recorder. So this is the flight recorder, and we should get a recording relatively soon. But to help the process a little bit and to make sure that there's something interesting to see, I use a second terminal, and I'm going to generate some load. So here I'm using a load testing tool called Hey, and I ask it to send requests for 10 seconds and 8 requests concurrently. So it ran for 10 seconds, and we got something like 8,000 requests per second served by this little service. There's even a little histogram. All of this comes from this Hey tool. But again, we just use this to generate some load. Now that the process ran for some time, I can terminate the process, and we indeed end up with a JFR recording. So IntelliJ IDEA has a tool window called Profiler. It's right here. And in here, you can see running Java processes. I don't have one right now, but I do have a JFR recording, and I can drop it in the second part of the panel. And now I can take a look at what's inside the JFR recording. So by default, we're starting out in this flame graph, and this is CPU samples. So native image JFR support CPU samples, and what we see here is where the time is spent inside this little application, this little server. So there's some run method and a handle method and a do filter. Then there's a handle get. Yeah, that's we did a get request, I guess, and we're listing some files, and it makes sense that we're also listing directories and that we're iterating through directories. And if we're going up to URI, okay, so we're checking some file path maybe, but definitely here we are going to do a system call to get information about files. And we see that here too. So there's is hidden or symlink is readable, right? So it's doing some checks on the files. And then eventually it will write to the socket, I guess, and close the socket. So yeah, this works just as if you were running this on a normal OpenJDK. But this is a recording from a native image. We can flip the view and look at memory allocations. And this is actually quite interesting. We see something similar, but if we scroll up, we always end up in something like emit object allocation sample. So it's here, and then there is this get stack trace ID, get stack trace ID. I think even here, get stack trace ID, get stack trace ID. And what this shows is that the dominating thing in terms of memory allocations is the JFR recording itself. So the service doesn't really allocate that much, but it's the JFR recording for CPU samples that need the stack tracing and allocation samples to function, and that requests stack trace IDs, and that is causing the allocations. So that's one of the few cases where like the monitoring really dominates execution, or like in this case, memory allocations. And yeah, we can look at the call tree and drill down if we want, or the method list. If I switch over to a memory view, we would see that emit and get stack trace indeed allocates the majority of the memory. Right? There's a timeline that you can look at, and you can even look at the raw JFR events. So for example, here we can see that there's no class loading. There's also no compiler event. Well, that's not really surprising to me, because native image, all of this happened at build time when I built the image. There's no compiler in this binary. There's also no class loading going on. There's garbage collection going on for sure. And some other events may not be, or are definitely not implemented yet. You can look them up on the website. But yeah, the initial system properties are also recorded. Here we can see my username, but also we can see we're using Oracle GraalVM and the GraalVM runtime environment. And the internal VM name that we use is Substrate VM. So this is indeed using native image under the hood. So yeah, so generally our idea or our goal is to get native image on par with all the Java monitoring features that you know. So you can already take heap dumps, you can take thread dumps, there's JFR support, and in this next release, in the upcoming JDK 24 release of GraalVM, we are also adding JCM and attach API support, which is also something that IDEs use. So so in the end, the goal is that you as the user, you get the same experience independently, whether you're running on OpenJDK, on Hotspot, or on native image. So, and if you want to like learn more about this, there's a guide on our website that shows you how to get started with just JFR. You can just do JFR and even do a custom JFR event. We have documentation on what's actually supported in JFR. So here's a list of all the events that we are supporting. For example, object allocation sample. We've seen this one, and the same. And similarly, we also have documentation for JCMD. But yeah, this is in an unreleased GraalVM version that we're going to release in the next year. So, and I should mention these monitoring features. We're collaborating with Red Hat on some of these. For example, JCMD was also partly contributed by Red Hat, yeah, it's very good that we're making a lot of progress with these monitoring tools. Okay, so next up is debugging. And debugging is something that we also often hear from users, like, how do I debug my native image? Well, first of all, I should make clear that, or I should say that native image building takes some time, and if you think you always have to debug the native image, then that's probably not the best way to do this. What the GraalVM team, or our team, tries to do is to make sure that the execution in native image is identical to what happens in OpenJDK or Hotspot. So if there is misbehavior or some difference, then it's typically a bug that we need to address, or it's misconfiguration on the user side of things. There's reflection, proxy configuration, and so forth that you need to do, or that frameworks need to do for you. And but sometimes there's a little incompatibility, and then we really need to be able to debug those problems. But what I'm just trying to say here is that it's totally fine for most of the problems to just debug them on OpenJDK or on Hotspot, and use that as you normally would, and then do the native image compilation right before you deploy. Right? Of course, you can build the application and then run some tests and then deploy it. But typically, I wouldn't build it and debug it immediately this way. But there are ways to debug GraalVM native images. So and IntelliJ actually integrates this. So yeah, the first thing that I want to show you is how to debug a GraalVM native image with the integration. So the IntelliJ idea team have moved the GDB tooling from C-Line into IntelliJ, and you can install the integration with a plugin called GraalVM Native Debugger. So if you install this plugin, then you will be able to debug native images. So now we need to find an interesting project to debug, and I thought we are going to use Spring Pet Clinic. So in case you don't know Spring Pet Clinic, that's like a sample application, relatively big sample application built in Spring Boot, and it can be built using Maven and Gradle, and it also builds fine with GraalVM because GraalVM is fully supported in Spring Boot. So what I've done here is I just cloned the Spring Pet Clinic project, and then I've added my bash scripts, or some bash scripts for building. So this again sets up SDKman, and then Gradle W native compile will build the native image of this application. Now, I didn't want to mess with the configuration. You can configure all of the flags for native image inside of build Gradle or the POM XML, but instead here I just decided to use an environment variable to inject additional arguments, build arguments for native image. So what this does is it adds -G and -O0. -G turns on debug info generation. So that means in addition to your native image, you get debug symbols. And then -O0 turns off compiler optimizations. So by default, you're running with -O2 or maybe -O3 if you're using PGO. But -O0 make sure that the compiler does not start to reorganize your code which would result in, if we're like going through the code in the debugger session, that you would jump from left to right and from like one thing to another thing because the compiler has decided to shift your code around. So if you're so we recommend you turn off compiler optimizations for the best debugging experience. So that's what I've done here. I believe the plugin also can do this for you. But I haven't used that yet. I just wanted to make sure that I have everything that I want in the right way I want it here. And then I ran the build already. So under build native compile, I got my Spring Petlinic native executable, and I got my debug file, which is the debug symbols. And then there is a sources directory. This sources directory contains a copy of all the sources, and the debug info is actually draw information, and that links into the Java sources. So now you may be wondering, oh, I said GDB, and that typically sounds scary to Java developers. Got some good news about that too. But what I want to say here is that no, of course not. We don't need to debug on the GDB level, on like the machine code level. We do need to have GDB connected here because the native image is a native executable. So we need to use GDB or some other system debugger to debug it. But as you will see in just a minute, we can debug it on Java source level because the debug info actually operates or has information encoded about Java sources. So now enough talk. Let me start the debugging session. So what I have, what you need to do is you need to add a configuration. And when you have the plugin installed, there's an attach and a native image configuration. I already pre-configured the native image configuration for this application. Oh, how do I get rid of this? Okay. And here it is. So what you can do is you can, of course, give this a name, and you can say where you want to run it. So here I'm saying I want to run it on a local machine, but you can also run it on a remote machine or in a Docker container. Docker container is very useful when you're developing on Mac, for example, or on Windows, and you're deploying on Linux. You can use this integration to build the app on a Mac computer in a Linux container and then start debugging. And I think that is a really cool user experience. But I'm already on a Linux computer, so I can just run it locally on my machine, and no need for containers. And I already set the executable path and the symbol file path. And I believe you can also add tasks like run the GraalVM build in Maven or on Gradle, and it will inject those debugging info flags for you. But I did this manually, and I don't need this step. So now it's time to start debugging. Okay, so when I click on debug, we don't see anything in the console because GDB is now loading the symbol file and is going to look through the source directories. But eventually, we should have some threads starting. And now we see some output from Spring. So this is Petlinic running. And yeah, so now we can start trying to talk to the service. And here is Petlinic running on my computer. Okay, so far so good. And I already pre-configured some breakpoints. So in the sources of Petlinic, there is an owner and a vet directory, and there's an owner controller, right? This owner controller has an endpoint called owners, in which you can use to search for certain owners. And I already set a breakpoint here in the first line of this thing. So why don't we try and trigger it? So this is the find owners form, and I can search for Davis. And when I do this, I should trigger the debugging breakpoint. And I just did. Here we are. So not so scary. We are in a GDB debugging session, but we're looking at Java code. Yeah, there are some addresses, but you know, you can like look at these things and understand what is going on. For primitive data types like the page, we can even see values. we can see the whole stack trace here. So this is the framework. Here's the framework, some parts of the framework internals. Here's Apache Tomcat calling into the framework, right? So I don't understand how any of this works, to be honest. But here, the framework uses Java reflection, and then we have some reflection support in native image, which is here, SVM core reflect, and then it's calling into the user code. So you can really understand what is going on in here, even though you are in GDB. Okay, but of course we can go and step over stuff and step in stuff, or I can resume and we hit another breakpoint, which is not too far away from where we were. So what's a bit unfortunate is that the string here, the last name, the value that I searched for, is not, we get the address. That's a little bug. I already filed a ticket for it, and the engineer working on this, one of the engineers has already fixed it, but I didn't dare to update, because I prepared this yesterday and it got fixed overnight. So, but we can still look at the value. So, we can click here and we can interact with the GDB session. So if I do P for print last name, I see I got a string pointer, and I can say last name value, which will give me the byte array, I think. Let's see. Sometimes this takes some time. Okay, and something was going on, maybe a garbage collect, something. So here's the byte array, the Java byte array, and in there I can say data, and this will print Davis. So that's the value that I put in there, right, in the form, and that's the memory address where this is stored. I believe I can even go here and paste it in here, and I will see the memory in the process. So here's Davis, right? So this is all kind of mind-blowing, and you can do this. So I must admit, I haven't used this much myself. But my colleagues do use the GDB integration a lot to debug problems in the garbage collector, problems of code generated by the Graal compiler, right? And talking about which, of course, you can go and say disassemble, and then you can look at the machine code, right? So again, I don't use this much, but there are very good use cases for this to go and debug through Java code and the machine code side by side, right? And when I resume, we should see the owner list and all the owners that start with Davis. So this extension is already doing a pretty good job, and it's being extended with more and more features. And I think this is really useful. But if you're still a bit too scared about GDB, I also have some good news for you. So one of the things, we want to terminate the debugging session. One of the things that we're working on, and which is on our roadmap, is JDWP-based debugging. It's been on the roadmap for quite some time, but I think I saw some pull requests popping up yesterday in here, SVM interpreter and JDWP support. So this is coming soon. And this will allow you to debug with JDWP, the Java Debug Wire Protocol, which is the normal debugging protocol that IDEs use to talk to an OpenJDK VM or hotspot. And then you get the same user experience that you would get from normal Java debugging. You get the same Java debugging experiences. So this is something that we already have been working on for quite some time. It's really not easy to build, but the JetBrains debugger guys already know about it as well, and they're also making sure that you'll get a really good experience for this in IntelliJ very soon. Okay, I think this concludes the first part of my talk, and maybe Mala has any questions. Let me check the chat.
Hi, Fabio. So we have a few questions. Let me bring that up for you. So this is by Yukin, and he is talking about like he mentions, he worked on a GraalVM project a while ago. Only issue I had was reflection in a deeper layer of a library. It took a while to figure what went wrong. Any tool, I guess, what you showed just a few moments earlier, I think that would work for this. Or would you like to add anything? We also have a volunteer from our team, and this is what he mentioned. So now you kind of can add.
Yes, that's right. So Vasily actually made a very good point. So we have this tracing agent for GraalVM. Here's the page that he shared. This is an agent that you can use to run your Java application with, and this will record reflection, resource usage, Java resources, and other dynamic features in Java for you, and it will spit out what we call reachability metadata, the configuration that you need to feed in the native image build. So yes, one of the main problems sometimes is that the reflection doesn't happen in your code, but it happens in one of the dependencies that you have. AWT is a good example. The frameworks, like the microservice frameworks, they make sure that they provide metadata for you. Yeah, you can use the agent to record it, or you can use the native build tools. And the native build tools, they already come with reachability metadata for a bunch of libraries. So here I'm on native image libraries and frameworks, and here's a list of different frameworks and libraries. And this is growing. The list is growing every month or week even, with new metadata that will automatically provide configuration for certain libraries. And of course, in the future, the best thing to support this would be if the libraries provide the configuration for the user, right? So if you run into these problems, Jürgen, then maybe also open a ticket against the library or framework that you're using and tell them you would like to see native image support, and feel free to see me on this, so we can work with the library author to make sure that their users will have a good experience when they compile with GraalVM.
Thank you so much. And there's another question. I believe the answer to the question of why use Python with a JVM language would be so that we can use the existing functionality, which is already there in terms of libraries or other things. But of course, you are a better person to answer.
Well, you know, like, why use Python with a JVM language? Well, the Python ecosystem is moving really fast. And sometimes there's no equivalent in the Java space. And sometimes it would just be easier if you can just reuse what's already there. We have LangChain4j, but there's no official OpenAI binding for Java, for example, right? And with GraalPy, you can use the official OpenAI Python bindings to talk to the OpenAI API, and you can use the latest version in your Java application today without having to port anything to Java, right? So that's one of many reasons why you would want to do Python in Java.
That makes sense. And there's another question I was wondering, because when you were talking about the profiling part, JFR. So we know that JFR is a profiler with the least overhead, and you mentioned a lot of calls from the profiler in the native image execution. So is there a better alternate that you have? Because that was the only profiler that I knew has the lowest overhead.
Well, that was my point. There was not a lot of allocations going on in the server, partly because the Graal compiler was able to eliminate allocations. I don't know. I haven't looked at the code of the simple web server myself, but it kind of makes sense. You're just going through directories and files, and you're trying to list them, and then we haven't done anything crazy with the server yet, right? But there could also be like maybe some room for improvement in our JFI implementation in native image. Maybe that is a bit too heavy. I don't know. But right now it's working fine, and that's just sometimes something that you see when you turn on tooling. Then sometimes you cannot always avoid that the tool does not like introduce some error or some new behavior in your application. right? And I just wanted to show that we can see JFR doing its work with itself, and yeah, that's pretty much it.
Thank you so much for showing that in IntelliJ IDEA. For everyone watching, I just want to tell them that yes, of course, you can drop your file in the view, but you can also start the application and attach a profiler with it. And of course, you can attach a profiler when you are kind of already started the application. So that makes sense. So there's one question that came in, and I will let you move forward with your session then. So to plan on adding more language alongside Python and JS, I think you already have.
Yeah, we already have a bunch of languages. I don't want to talk to about too many languages at the same time, right? We have WebAssembly support. We have another language, regular expression language in Truffle, which is actually baking all other languages. We have Ruby, Truffle Ruby. We also have Espresso, and this is where it gets really crazy because it's a Java implemented in Java. So this is like a meta-circular Java VM, kind of mind-blowing. You can use that, for example, to embed Java 8 code in a Java 21 application. Right, so there's all kinds of crazy use cases for this thing. But yeah, there's a lot of open source third-party languages implemented in Truffle. Before I joined the team, I wrote one myself, a little Smalltalk VM in Truffle. So there's a lot going on, and as I said, you can even write your own and make use of our tooling infrastructure.
Right. And this is the last question that I want to take before you move forward with your second part of your session. So I've tried GraalVM with Spring Boot twice, failed because of problems with OpenTelemetry dependency in my Spring app. First try, and then there's a follow-up comment. Now I'm kind of demotivated. I guess they could follow the example that you have on your website. I think there's a lot of steps that they can follow and get their work application started, I guess.
Yeah. Well, OpenTelemetry comes up from time to time, and maybe we even have a guide or a demo somewhere. I don't know where we are right now. The problem with monitoring tools sometimes is that they do bytecode manipulation at runtime. And as I've shown you in one of the demos, we don't have a compiler, we don't have class loading, we don't even have Java bytecodes anymore. We have machine code, right? So you cannot instrument Java JVM bytecode at runtime anymore. But we are actively working on making this easier and even very easy. I think Alina shared something about OpenTelemetry not so long ago. So maybe, maybe you could take another look sometime, and maybe we can follow up with some links for OpenTelemetry monitoring. But the same is true for other monitoring features that heavily use bytecode instrumentation.
Thank you so much. I'll let you move forward with your second part. Thanks.
Okay, let's go. There is a couple of minutes left, and I try to be not too quick. But so the second part is about Graal Languages, which you can use to supercharge your Java applications with the power of other language ecosystems and reuse code that others have already written or that other teams have already written in your company. And for GraalPy, I wanted to show you there is, of course, a Python plugin. You may have already seen it. So you can install a Python extension. I think I'm using Ultimate here. So this is built on Python Community Edition, and it provides you with the PyCharm IDE features. And that allows you to set up additional SDKs. So you've already seen my Python SDK setup here. And then I can also attach this and use this Python SDK in my projects. So that's very good. So you can even use GraalPy with this plugin, and then you have a little console, a Python console, or there is a Python package list that you can look at. I don't want to take a look at them too much, because what I want to show you is a little demo. So let me start the application. What I have here is a little Micronaut server. So after we looked at at Petlinik, let's take a look at a Micronaut server. So this Micronaut server serves a little website, which is here. And this does sentiment analysis. So I can type in a text like the new GraalPy release is not too bad, right? It's not too bad. So yeah, that's a positive statement. I can do something like live streams make me nervous sometimes, right? We can also try something out like fruits. Yeah, that's indifferent. Or we can try to be clever and say, don't forget to smile or smile today. And it even looks through emojis. Right. So yeah, this is a really simple app. It just does some analysis, sentiment analysis on the text. And depending on whether the value is, I think, between -1 and 1, we get a different emoji or different smiley. What's more interesting, though, is how this thing is implemented. So let's take a look at how this works. You can find it in our demos repository as well, linked here at the bottom, GraalVM/Graal Language demos. So that's just a simple Micronaut application, and there's a GraalPy context which sets up contexts. Maybe I should talk about this just a little bit. So I was maybe a bit too fast. So on the GraalVM website, you can find the languages here. For example, GraalPy. And GraalPy is really just 2 dependencies away, right? So here, the Maven or the Gradle stuff that you need to copy over, and then you can create these contexts that I'm about to show you. And with these contexts, you can evaluate Python code. And we even have a little plugin that allows you to install Python packages if you want this. So I'm already using this in this application, and here I'm creating these contexts, and I wire this up with the virtual environment that the plugin creates for us. It's really easy. You can see that we have a guide on this on the website. So this is just to make sure that we can inject contexts. And now we have this demo controller, and the demo controller serves our index.html. And it also has a REST endpoint analyze. So the index.html is just a static website, the website that we've just seen. And analyze serves an application JSON, produces an application JSON, depending on some text. So far, so good. It's using a sentiment analysis service, and on which we call get sentiment score. And it returns a map of strings to doubles. Okay, so now let's take a look how this guy is implemented. So this takes a string and calls analyzer polarity scores text and returns the value. And the analyzer is a Java interface. We can see it here. This is the interface. Well, here's the interface, and here is the field, the analyzer. So this is a Java interface that is using Java types, but you can see this method name is a Python method, and we kind of can hide the fact that it's a Python method by putting this into the service and using this as an implementation detail. But now the question is, how do we get a handle on this? So here we inject a GraalPy context, and then we can evaluate some Python sources. And what I'm using in this demo is a Python package called Veda Sentiment. It does sentiment analysis, and it provides a sentiment intensity analyzer. So that's a mouthful. So we evaluate the sources, and then which instantiates one of these analyzers. And then we have this very cool method called as on value, and you can provide a target type. And this is where it's really crazy. Here we can instruct our Polyglot API in GraalPy to represent the Python object as a particular Java type. Right, so in GraalPy will take care to create a proxy object at runtime, which will forward all the messages, and it will do the type conversions for you in a very efficient way. So now the one thing that I haven't showed you is, well, this says Python, because I put in a comment language equals Python, which will turn the next string into, well, a Python string. So this is called language injections in IntelliJ, and I think it's super cool because you can do all kinds of crazy like auto completion. You get documentation in here, right? So this returns a float for sentiment strength based on text input, and it returns based on a text. It returns a dictionary of strings to floats, which we then convert to a Java map of strings to doubles, right? So that's the method that we're calling here. And of course, you can do all kinds of stuff. You can import. So like calling exit is probably not what we want to do, but you can do all kinds of stuff in here because it's really just a Python IDE inside of the Java IDE now. And I think that is super cool. So you get auto completion, you get documentation and whatnot. And I think, yeah, this was very mind blowing when I tried it out, and it's working really well with GraalPy and the other languages. Okay, so now that we understand how this works, let me show you one more thing. Well, maybe let me go back to the docs. So we talked about the Python plugin, the language injections, and now I want to show you the endpoints tool view. So there's this endpoints tool view. I guess you can also find that here, view, tools, endpoints. And this one is really clever. It supports a whole bunch of different frameworks. But in my project, I have my Spring Pet Clinic. But down here, I also have my sentiment project with this analyze and this and the main request endpoint. And we can submit requests right here. There's this HTTP client in IntelliJ. So I thought, well, you can even, there's OpenAI, there's documentation for the endpoint, and you can even generate a curl instruction for this endpoint. Super cool. But this HTTP client is really fun. So I thought I'd write a little test in it. So still have the servers running. So down here, I have a little test. So this is test the web page. This gets the main page, and then it makes sure that the content type is correct. Then I have a test for a positive request where I use the text, this is funny. I even can use variables, which is kind of cool. So, and I use the analyze endpoint, and I set text to the text value, and I want application JSON data back. And a part of this request returns a compound value, and this compound value, I just want to make sure that it's positive. And there's also a negative test, which uses this is not funny. And then we want the compound value to be negative, right? And this is something that I found out about only recently. So I'm not really up to speed. There's a lot of examples that you can look at, but I can run these all. And then I get this little view in my services tab. And all of the tests, they succeeded. So this is the content type is correct test. I can even look at the response. It saved the HTML file on disk. Can also see the compound value is positive. I can see the response. This is what the response looks like from the service. And I thought this is a really cool thing that you can use inside of IntelliJ IDEA to write tests and to interact with your microservice while you're building it. And it works with Micronaut, it works with Quarkus, works with many things. Yeah, so in case you are wondering, this is really JavaScript here, right? So you can do JSON parse, and this is running JavaScript. Hold on, isn't IntelliJ running on a JVM? Yes, it is. But how is it then running JavaScript code, you may be wondering? Well, here's the little twist in case you haven't realized. Well, this HTTP client is using GraalJS under the hood. So since the 24.2 EA build 5, GraalJS is now the execution engine for the HTTP client in IntelliJ. So all of the JavaScript actually runs on GraalJS. So in case you're wondering who is using GraalPy, GraalJS, and so forth in production. Yes, there are companies doing that in production. And if you are an IntelliJ IDEA user and you have used the HTTP client, then you're already using GraalJS under the hood, which I think is super cool. Yeah, it just demonstrates how powerful our languages are. Okay, not too much time left. How about we stop with another debugging demo? So you can write your Micronaut service and embed Python in it, and you can test it with JavaScript in an IDE that runs on Java, which is kind of cool. But what if something goes wrong and you want to debug it, but you don't want to debug it on the Java level, you want to debug it on the guest language level. So you want to debug the Python code, the JavaScript code, or so forth. Well, I have a little project here. It's a one-file project, really simple one. Let me get this out of the way. This is my app. It creates a context, you know, the one that you've seen on the website. And this one can also do JavaScript, because JavaScript, just like Python, is just two Maven dependencies far away. So if we take a look at my little script here, I've got the Polyglot API, I've got Python, JavaScript, and I got some tools. And that's what I want to show you. So the tool is the inspect tool that I want to use, and I set inspect to 4242. Don't worry about this, it's just for the demo. So, and what I want to do is I want to evaluate JavaScript code, this JavaScript code, which is highlighted with a language injection. Pretty cool. It even knows that, you know, this is a recursive call for factorial, kind of cool. And then underneath is, oh, I just clicked on it, but it's still working. So this is my Python language injection. This is some Python code. So I'm evaluating some JavaScript code and then afterwards some Python code. Now let me start this. Okay, because I set this option inspect and I provided the tool, I now end up in a debugger session by default. And I can copy this link into Chrome and start debugging in Chrome. But IntelliJ IDEA also integrates the Chrome Inspector protocol. So instead, I can just click on this link and I will end up in a debugger session inside of IntelliJ. So now I'm on the first line that is actually doing something. So this is just declaring a function. And here we're writing something to the console I can step into. And of course, I can, you know, like look at the stack and step in and whatnot, right? We can even evaluate expressions in here. So what's going to happen is in the next line, let's see. So here's the debugger console. So we printed factorial 4 is 24. And what we can also do is there is this Java helper in GraalJS. So if I do this, it evaluates to the Java lang math type or the class. And this contains Pi or E, but also a bunch of math functionality that you know from Java. So all I want to show you here is that you can talk from Java to JavaScript. And in JavaScript, you can also talk back and call back into Java, right? So, and you can debug all of this in here. So now I'm stepping over, but there is no more line. This is Pi, by the way. Oh, and this is where it gets a bit crazy, but we're almost at the top of the hour. So I think it's fine if we like stop crazy and crazy. So here we're in the first line of the Python code, which is the second part of the application, right? So I can resume and we can break here at this breakpoint, and sys implementation name is GraalPy. And same thing, I can step over, I can step in, I can walk through the code. Well, you can see that you may have noticed that things are a little bit messed up right now, because we're debugging Python code and the IDE thinks it's still doing some JavaScript or TypeScript. So it couldn't really figure out that dev and Java, that's a function declaration and import from and whatnot. This is all Python, but it works, in here, and in Chrome browser it would work too. If we want to fix this, well, there's of course a way that you can fix this in IntelliJ IDEA. But what would also be really cool, and that's maybe a feature request, and maybe one day we'll see that in IntelliJ IDE, is debug adapter protocol support. We have that for Graal languages. It's not in IntelliJ yet, but maybe one day we'll get this, and this will bring us true Polyglot debugging experience in IntelliJ. And yeah, if I resume, we can see fib8 is 21 and mathpy is still the same, because we were actually talking to the same Java math class from within Python. So if you find this interesting, go check out our demos. We are adding demos and guides every other week. I'm going to add the debugging demos very soon. We have some cool GraalPy demos. We have some JavaScript demos and some WebAssembly demos. And we'll show you how you can use them, for example, even in IntelliJ IDEA. And with that, I am now a minute over time, but I'm still ready to answer any questions that may have ended up in the chat. So Mala?
Hey, Fabio, that's such an interesting session. It's amazing how you kind of managed to cover so much in one session. You talked about theory, you had so many demos, which all worked well. What did you do? Was it all staged or was it live?
Well, I just practiced a little bit, and honestly, maybe I just got lucky with DemoGod. I prayed to DemoGod this morning. So yeah, I'm glad all worked out, and I didn't end up in having to fix anything, but the tooling is very solid, so that makes it really easy to work with. And are there any questions in the chat?
Yes, so a lot of comments about how good the tooling and the session has been. Let me bring them up just a moment. Yeah. And before we do that, everyone who's watching, we would love to have your feedback. We just a couple of questions in the survey, just 2 to 4, and it will take you 1 or 2 minutes to fill up the survey. That really helps us to kind of think about the next sessions that we want to have on our live streams. Now, let me show the questions. Okay, so we have a lot of folks. So this was a thank you message for the question that you answered earlier. And we have Deshaun on the live stream. And
of course, Deshaun is watching.
Yes, and Chandra is here too. And Deshaun said, because Chandra is here, the party's already started. So Deshaun also added, I think, to one of the earlier questions that was asked about the metadata repository. So that's great. Deshaun, even though he said he's late to the party or to the session, but he was kind of happy to be contributing, which is great. So this is, I think, a great use case that could be used for, because there was another question like, where do we use Python? So Deshaun mentioned that he works with data scientists, and his move is to wrap their Python as GraalPy in a Spring Boot application. So that is good. And you also mentioned another great example where the HTTP client already uses GraalJS in IntelliJ IDEA. So that was great. There was another question. Okay, another comment. Deshaun, I don't have cloud money. I have Raspberry Pi money, so I can use GraalVM everywhere. And then, so there was another comment. So it's like Graal, everything in your life. So that's interesting. Probably you could use that as an interesting naming thing in your tool product. And Deshaun was kind of blown away by the demos that you had when you were talking about debugging the GraalJS demo that you had. So that was good. Chandra also said, wow. And there's another question, film music videos. And the question is it working with Python packages that use native library, for example, TensorFlow? Is the memory duplicated when passing from Java to the Python context? For example, a big Java byte array.
Yeah, that's a very good question. And this tells me that Phil really knows what's going on under the hood. So yes, Python packages often use native extensions, and those work with GraalPy. Most of them work with GraalPy. We still consider the integration somewhat experimental, but something like TensorFlow, PyTorch, NumPy, they work with GraalPy, and we're actually working on building them for GraalPy so that users don't need to build them from source, which will make the user experience better. That is one of the things that we're currently working on. The other part of the question is the memory duplicated? And Phil, maybe take a look at the roadmap for GraalPy. We have an item for first-class support for Apache error. So that's going to land in the next GraalPy release, which will allow you to use error, JError, I think, to create your data structures and then pass them onto Python, like PyTorch. And then and we will make sure that there is no data duplicated. So you can have a really big, but not even just a byte array. A byte array can only store something like 2 gigabytes, but even beyond 2 gigabyte data in a JError data structure, and we can pass that to the Python side into the native extension without with zero copy. So there's no copying going on, and it will be super fast and super cool. So we are working on making the machine learning world even easier to access from within Java. But the first step here that I wanted to show is that we have the main thing, the Python language itself, up and running with experimental support for native extensions.
Thank you so much. There's another question by GT, and I think it's a compliment that was insane about one of your demos. The question is, I'm not sure if I got it well, but is it easy to call Java code back from the Python code that was invoked from Java?
I think GT is asking about callbacks, and yes, you can do that. So you can pass in a Java Lambda into Python and call it from Python, and vice versa. You can create a Python Lambda and pass it onto the Java side and execute it. So that's definitely working, yes.
There's another question. This is by Ashish. Really like that the language injection and the context work like a runtime IDE of another language within the code. That is really cool. So it's more of a comment, not a question. Okay, so with that, no more questions. That is good. Another comment which says, so this is by Chandra. He is saying amazing session. And there's another comment again, amazing session by Sunil.
Great. Well, thank you all for tuning in. This was fun. I don't always get to demo an IDE because I'm not working on one. I'm working on the GraalVM team and the languages. We are almost at the end of the year. So I wish all of you a Merry Christmas season and also a Happy New Year.
Thank you so much. That was an amazing session. And thanks to everyone for watching, for asking questions, for answering questions, especially to Sean and Chandra. And yes, for everyone watching, you can view the links on your screen right now for the socials, for IntelliJ IDEA, and also for Fabio, because if there are any questions which you want to kind of have more information, feel free to ping either us or Fabio, and we'll try to get the answers to you. And on that note, happy holidays, everyone. Yes, do not miss to subscribe to our channel. Yes. Thank you so much once again. Fabio, do you have any closing comments before we close the stream?
Yeah.
Okay.
Happy festive season and see you around.
Yeah, so happy holidays, and we'll see you again for the next live stream soon. Until then, bye-bye.
Ciao.